Okay, let's give you guys some more practice. So here, let's say I've got a sheet of paper here. I've got a sheet of paper here, and then I'm going to roll up this sheet of paper into a cylinder. Okay, and the question here is to optimize the volume of this cylinder. So the volume being well, the area of this here would be pi r squared. The volume would be pi r squared times h here. Okay, so the volume is pi r squared times h. Well, the constraint is that the perimeter of this sheet of paper must be 20. So optimize the volume. So what must x and y be in order to maximize the volume here, the volume of the cylinder? So press pause and have a go. Okay, so to do this here, this here is our constraint. So this here, so if you have your rectangle here, this is x, this here is y. The perimeter must be 20. So this is our constraint here. And now, if you look at the sheet of paper here, this bit here corresponds to this, and this corner here corresponds to this. So the circumference here must be x. Okay, so the circumference here, the circumference must be x. Okay, so well, basically we're trying to come up with a term for the volume of this cylinder here. Okay, so the circumference here, the circumference must be x. So we put the x into the c. That would then take us to here. Okay, so divide both sides by 2, blah blah blah, and then so you've got your radius here. So this is your radius here. We need to work out the area. Okay, so yeah, looking at this diagram, we need to work out the area here. So the area is pi blah blah blah. The volume here is this. Okay, the volume of the cylinder is this bit here. So what we've got so far is this is our perimeter. Okay, this is our constraint here. The volume is given by this. Okay, and then well, simplify this. Divide everything by 2. That will then give us this. So basically, this is the same as this. Okay, and then rearrange it to make y the subject. So that will give us y equals this thing here. So now we can put this thing here into the y here. So we have a volume as a function of x. Okay, so yeah, so put this into here. That will then give us this. So the volume is given by this. Multiply it out. Multiply out the brackets. That will then give you this. So now quickly sketch this, just so that you have a rough idea of what's going on. So here we've got a graph of volume versus x here. Okay, so volume is a function of x here. Looking at this here is like me asking you to sketch this graph here. Y equals positive x squared, take away x to the power 3. It's similar to me asking you to sketch this. So from our section on sketching graphs, when x is small, it wants to do this. When x is big, it wants to do a negative cubic. So when x is small, it wants to do this, a positive quadratic. And then when x is big, it wants to do a negative cubic. Okay, a negative cubic. So so we can guess our graph to look something like this. Hang on. So there. Okay. So we're going to guess it to look something like this, because when x is big, it wants to do a negative cubic. When x is small, it wants to do this. So we're going to guess our graph to look something like this. Okay, so now we need to find out this point. You can see that there's only one. If you differentiate it, there should only be one. Well, apart from this bit here, there should only be one point where the derivative is 0. So hang on. So looking at this here, differentiate it. That will then give you this. Okay, so differentiate it will give you that, and then set the gradient to be 0. So set this thing here to be 0. So find x when the gradient will be 0. So factorize it, so we then give you this. So looking at this thing here, this whole thing here, sorry, hang on. This thing here will be 0 when you make this 0, or when you make this 0. Okay, let's just concentrate on making this a 0 here. Make this a 0. So concentrate on making that the 0. So blah 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 x equals this. Okay, so what that means is that what if x equals 20 over 3, if x equals 20 over 3, then y if x equals 20 over 3, then y must be 10 over 3. Okay, so here's your answer.